Hello, welcome to Maths is Not a Mystery. Today we're going to be looking at collecting like terms. It's an algebraic system, and collecting like terms means collecting together all the things that are the same as each other. Like terms actually means terms. Each one of these letters, or a number if you have a number, is a term. Like terms are the ones that are like each other. So starting off with really easy things, not a problem. Here we've got an A, which stands for a number, but we don't know what it is, plus an A, plus an A. We've got three A's there, and to collect like terms together and simplify this, we just write down how many A's we've got. That's nice and simple, isn't it? Of course, it won't always be that simple. In the next question down, we've got A's and B's. A little bit more tricky, but all we need to do is we need to collect up all the A's that are together. So we've got an A there, an A there, and an A there. So we've got three A's. And we've got a B there and a B there. We've got two B's. We don't have to work out the answer to that when we're collecting like terms. We don't have a clue what the answer is. We don't know what the A's and B's stand for, but we do know that we've got three A's and we've got two B's. That's as far as we can go. Now, the complication in the next question is that we've got some minus signs in there. When we've got minus signs in there, I'm going to give you a little bit of important advice. You see how I circled these others to make sure that I'd collected them all and hadn't missed any out? When you've got minus signs, circle the letter of the term, whether it's a letter or a number, and also circle the sign that comes ahead of it. Now, there is no sign here. If it was minus A at the beginning, there would be a sign ahead of it, but this is a plus A. So circle the A. The next time we've got an A, it's got a minus sign in front of it. So circle the entire thing and circle the next entire thing. So now I've got A minus A, which takes us down to nothing, plus A, which takes us back up to 1A again. We don't write 1A, we just write A. Do you get that? We've got one single A, then we take an A away, so we haven't got any, and then we add one back on, so we've still got one. Now the B's, we've got a plus B, a single plus B, and then another plus B, so that's two B's. A plus 2B. So always circle the sign, or include the sign there, so that you know whether to add or take it. Alright? If these B's, if we'd have had more minuses than pluses, and we'd have ended up with minus 3 B's, then this sign here would have been minus instead of plus. But because we've got a B and another B, and I've just said it's 2B, that means it's plus 2B. That's the adding and taking part. If we now go into multiplying things together, well, it's not much different. In algebra, of course, we don't usually write a times sign. Two specific things we don't write in algebra. One is a number 1, we just write the thing on its own. The other one is a times sign, and the reason for that is because it could be confused with the letter X, which could be an algebraic term. So when it's A times B, it's AB. It's as simple as that. If it was A times B times C, it would be ABC. We just miss out the times sign. If it's A times A, we don't bother writing AA. We could do, but it's not fully completed. A times A, just like 5 times 5 is 5 squared, A times A is A squared. And, of course, following on from that, A times A times A, because it's a times sign in between them, it's A cubed. Okay, so far so good. As it gets a little more complicated, we've got a bundle of different letters here. So let's take a look at what we would be doing here. We've got a set of A's. We've got A times A times A times a. 4 of those. I've not circled the times sign because there's no issue with it being minuses there. Nothing on that line suggests that there are any negatives. So far I've got 4 of those a's. Now if they'd have been plus a plus a plus a plus a, that would have been 4a. Because it's times, it's a to the power 4. And then we've got some b's. We've got one there, we've got one there. 2 b's. Not 2b, however, because these are multiplied, it's b squared. We don't write the times sign, we just simply write the new thing next to it. That leaves us with a c on its own. There we go. A to the power 4, b squared, c. There is, if you like, an individual times sign between each of those letters, but we don't write it because we don't write times signs in algebra. Okay, now what happens if we move on and put some numbers in with all of that? Here we go. Now this time we have 2a times 3b. So what do we do with that? Well, this time round, the like terms, there are 3 of them. One set of like terms is numbers, real, actual numbers. Another set of terms is a, and another is b. Start with the numbers. 2 times 3 makes 6. A times b is ab. The answer to that question is 6ab. So we multiply the numbers first, and then we multiply the letters together. Now on the next question down, we don't have a letter every time. We've got 2 times 3a. This time we've only got 2 terms. One term is the number term, and the other term is the a. So do the numbers first. 2 times 3 makes 6. And it's 6a. 2 lots of 3a is what it's asking us, and 2 lots of 3a is 6a. Now on the next one, a little more complicated again, because this time round, as well as having numbers, the terms on both sides of this times sign are the same term. So what we've got here is 5a times 6a. 5 times 6 is 30. So the numbers part is dealt with. A times a, well, when a times b up here was ab, a times a, of course, is a squared. So the answer to that question is 30a squared. Now, if you've watched the index rules video, you'll probably know how to do the next one. We've got a squared times a cubed. Now, if you think about this, let's just think what this would be. I'm going to put this in brackets before we start answering the question. A squared is a times a. And then there's a times sign. And a cubed is a times a times a. How many a's have we got there? 1, 2, 3, 4, 5. Okay, and that's a to the power 5. Not 5a. That would be if you were adding them. You don't have to write it out in full like that because you've got your clues already. A squared plus a to the power 3, a cubed. You add those 2 powers together. 2 plus 3 makes 5. So it's a to the power 5. I've just written it out there to show you how you derive a to the power 5. But you don't need to do that. All you need to do is know that you add the powers together. So let's now include that in the next question. We've now got 2a cubed times 4a squared. Well, the first set of terms are the numbers themselves. 2 times 4 makes 8. That's dealt with your numbers. And now we've got a question left over that's similar to the question above. A cubed times a squared. It's going to be a to the power 5 again, because we've got 3 plus 2. All right, so multiply the numbers together and then multiply your powered terms together. On to the final one, 2b times 3b squared. Now be careful with this. This is the kind of thing that is actually a little bit easier than the one above, but I put it later because more people get it wrong. Start off with your numbers. 2 times 3 makes 6. Now look what you've got next. You've got b times b squared. That b there, the first b, if it had a power attached to it, it would be a little 1. But we don't write a little 1 because every number would have to have a little 1 next to it if we did. Everything is to the power 1 unless we tell you differently. So this is b times b times b. Let's just write that down there. The first one is b, and then the second one is b times b. So there are 3 of them. It's b cubed. So you've got to remember that that has a power of 1. 2 times 3 makes 6. B squared times b, or b times b squared, means that we've multiplied it together 3 times. Okay, so don't be caught out by that. The b and the b squared do need to be combined to become b cubed. Okay, so now that leaves us with one final thing, a bit of a monstrous question that we're going to take a look at. Here we are. This time we've got something that's got plus and minus in there. There's no multiplication, but it's got a combination of terms in there. It's got numbers, it's got x's with powers on them, and it's got regular x's. Now if you come across something like this, what you need to do is you need to get together all of the like terms, and you need to rearrange your equation, or your expression, so that it shows that you've pulled them together. Now my suggestion is that you do in this situation, do the x squareds first, and then the x second, and then the numbers third. Let me show you what I mean. So in terms of x squareds, we've got this. We've got 2x squared, and there's another x squared here, put that circle around the add sign, plus x squared. All together there, then, we've got 2x squareds and another x squared, and that's 3x squared. Now the regular x's, we've got 4 of them, minus 5 of them. 4x's minus 5x's leaves you with minus 1x. We don't write 1 in algebra, so it's minus x. Look back at the original question, and now you've got the third element, the numbers, and the numbers say we've got 3, and they say we have minus 2, which equals 1. We do write 1 when it's a number. If we didn't write 1 when it was a number, there'd be nothing there. We just don't write the 1 in front of letters. What we've got down in this vertical column at the end of our equal signs now is the simplified version of that across the top. When we've collected all the like terms together, we've got 3 lots of x squareds minus x plus 1. So that top line has now become this bottom line. Okay, that's collecting like terms. I hope you've enjoyed it. Thank you for watching Maths is Not a Mystery. Subscribe if you enjoy. Thanks.